Jordan, I need you to talk because I don't think you have your mic on. Can't hear you. Try to check your screen and see if you have the mute pressed.
How's that?
I can hear you better.
Okay. So, yeah, the mic. Is that better?
Better.
Okay. There we go.
All right. There is some static caused when you're talking sometimes, so just make sure you hold it carefully and hold it up to your face to have the sound go. Say testing, testing, 1, 2, 3. Can't hear you. Is it possible for you not to use the headphones? Try to talk without the headphones on and let's see. Hi, Emily.
Hello.
All right, so Jordan, you're still having problems with your mic even without the
I can't hear you.
Okay. I'm not sure why. Testing, testing. Can you hear me now? James, can you help me? I don't know what's going on. I couldn't hear Jordan, and Emily Mungle just said she can't hear me. Jordan was talking with me and was able to hear me before.
Okay, so her hearing you is her problem.
So Emily, nope, she's not. Okay. Yeah, I was just checking.
And the fact that you can hear it makes the fact that you can't hear Jordan a very problem.
All right, let's see. How's that?
That's better, Jordan. Can you hear me?
Yes.
There you go. Half step troubleshooting method.
All right, so that's a message to Emily. Jordan, I'm trying to get Emily. She said that she can't hear me, so I'm trying to get her to check her side.
Okay. So I can go ahead and say that I've watched all 3 videos and I've read the 2 sections in the chemistry book. And yes, I'm taking notes on them.
Good. All right, so I will check those notes on Thursday. And you said you watched all 3 videos for chapter 13?
For chapter 13.1 A and B, and then chapter 13.2.
Got it. Okay, that's perfect. So that works out very well. I will check your notes on Thursday. You should add to that. By Thursday, you should have watched the videos for 13.3.
Okay.
So I will check all of that on Thursday. We also have our project due on Thursday. So I'm going to, at the end of today's lesson, open up time for any questions that you guys might have about that project. And as people have questions, they can stay on. If they don't have questions, they can log off and leave. Emily,
I think all I need it'd be nice if you could put like a picture of what's required for each of the slides on Edmodo, and I think that should be fine because I have PowerPoint here and I can just work it from there.
I am not going to give you guys like this is what it should look exactly like because
no. I was just saying like the list of what's required on the slides.
Okay, I already have a list of what's required on the slides.
Oh, is that already on there? Okay, I guess I did.
That is already on. That's the rubric or the idea of what I want is already on Edmodo right now.
I'm checking right now. Hold on. Oh, okay, here it is. Yeah, I have it.
Okay, good. So now we're on the same page. We're all good.
Yeah, in case my questions are answered because I have PowerPoint on here.
Okay. All right. So we're waiting now. Emily left the group because her computer, I guess, was acting up. She's going to join back on, and we're still waiting on Emily Carr. Let me text her and just make sure she is planning on joining.
Okay.
All right. In the meantime, Jordan, we are going to need our book. You're going to need a calculator and some pen and paper, or a pencil and paper. So you're
As for calculator, I have a calculator on my computer that does do scientific, and then I have my notebook and my book right here along with.
Good. Now I want you to make sure, Jordan, that you are writing down all of the work for every problem. Okay, so as we're going through these, I want you to actually have every step written out, so that you can go back and look at them after we're done.
Okay, I'm gonna try and get some light here because I'm pretty sure it's gonna get annoying looking at a silhouette.
The window is really causing a bad glare, because it's.
That better?
That's a little better, yeah. If you could angle the computer over a little bit, it would be even better, but that's fine.
That better?
Yeah, that is better because you're not like a dark shadow. No, go back.
Nope. Okay, blind.
That is better. All right. I'm not sure where the ladies are, and I'd like to wait until they join the class to start, but you know what? I will catch them up in a second. Jordan, you can start working for me. Today we're just going to do a lot of practice for the math. The chapter 13.1, you have one equation that will help you with all of the math problems. Do you remember what that equation is?
Yes, I think I wrote it down. I don't remember it because I didn't memorize it, but I should have it written down here.
You should have it written and you should memorize it.
PV divided by NP.
That's the ideal gas law. We're talking about the combined.
Oh, that's PV equals NRP.
No, that's the same one that you just said. Look for the combined gas law. Find the combined gas law.
Oh, okay, here it is. PV divided by T equals PV divided by T. And of course, with you have T1 times V1 divided by T1 equals T2 times V2 divided by T2.
Yes, that's the combined gas law. Look, if you memorize that equation, all of the problems in 13.1 they all make sense.
Okay.
You don't have to memorize Boyle's and then Charles and then Gay-Lussac all separately, because the combined gas law combines all three of those into one equation.
Okay.
So all you have to do with this is, if you know that one, just plug in the variables that you have and ignore the one that's missing. So if they give you a Boyle's, they're going to give you a pressure and a volume, and then maybe a second pressure, and they're going to ask for a volume. So in that case, you would just know that you need to multiply pressure and volume, and you ignore the temperature.
Okay.
But with the combined gas law, I don't know about you, but I don't like memorizing 5 different equations if I only have to memorize one.
Yeah.
So memorize the combined gas law and know how to apply it to the others.
Okay.
If you are ready to go, I would like to start, and the ladies may just have to rewatch this and jump in when they get here. So I would like you to start on page 443, and I would like you to work with problem number 1.
Okay. Problem number 1. Is that okay? So the volume of gas at 99.0 kPa is 300 ml, and the pressure is increased to 180 kPa. What will the new volume? What will be the new volume?
Your sound is really echoey.
Oh boy.
Yeah.
Is it like there's another person talking, or?
No, it's just echoey. But just keep working. It's okay. You're gonna have to talk slowly when you talk, because
Turn the volume down on his microphone.
James said you need to turn the volume down on your microphone. It's causing the problems.
Okay.
Bottom right of the screen, little speaker, right click that, go to your sound properties.
He said to go to the bottom right of your screen. You'll see the little mic, and you'll be able to turn it down there.
Oh, okay. Wait, is that on this thing or is it like on my? Well, I don't have a microphone. I'm using the microphone in this computer.
Yeah, I know. Turn the computer mic down.
Oh. Okay, hold up. Nice. Bitfinder power. Zoom meetings window. No. Nope. Okay. How's that?
Keep talking.
Is it echoing as much anymore?
Yep, it's a little better. Yep. All right, so now go ahead and start working on number 1. You don't have to read it to me, just start working on it, and I'm going to check your setup afterwards. So I want you to solve, you're looking for volume. All right, so plug and chug where you have in this equation and solve for the new volume. Remember that with volume, it doesn't matter if it's in milliliters or liters. As long as both units are the same, you'll be fine.
Can you tell me? Okay, so V stands for volume.
Yes.
P stands for pressure.
Yes.
What does T stand for?
Temperature.
Temperature.
In Kelvin.
Okay.
Temperature must be in Kelvin when you use it. Anytime you're using any of these gas laws in all of these chapters, you must use Kelvin.
So, is KP, is that like molecules that are in the periodic table? Elements on the periodic table?
No, no. Jordan, remember chapter 12, how I told you guys you had to memorize your units for pressure?
Mm-hmm.
Why did I tell you you need to memorize them? Because this is a unit of?
Measure.
It's a unit of pressure. I want you to go back to page. Hang on.
It's working now.
Go to page 407 and see the units of pressure. What are your units of pressure? So that when you see a pressure, you can recognize it. Emily, can you hear me now?
I can hear you now. My computer it froze. That's why I had to restart it and everything.
That's okay. All right, so Emily, we've been kind of catching up on a few things and getting started. So I want you to start with us on page 443. You're going to need a calculator, paper, and a pen or a pencil.
Do what problem? Page 443?
Starting on number 1.
Okay.
And Emily, I reminded Jordan that if you know one equation, you don't have to memorize all 5 equations from this chapter.
Mm-hmm.
That one equation is the combined gas law. So remind me of what the combined gas law is.
I don't really know.
Go find it. It's in your section, 13.1.
You just froze.
What?
You said it froze, so you said
Got it. It's in section 13.1. It's the very last thing in that chapter section. It's on page 49.
P1 V1 equals P2 V2.
That's just Boyle's. That's not the combined.
P1 V1 over T1?
Yes.
Yeah.
That's the combined. Here's why you only need to memorize this one. Look, read the first problem for me.
Okay, sorry. Put back, it was 447.
444. Hang on.
443. Okay. The first problem is V1 equals 0.75 L. Oh, wait. What am I looking at? Practice problem. The volume of gas at 99.0 kPa is 300.0 milliliters. If the pressure is increased to 188 kPa, what will be the new volume?
All right, look. In this equation,
Mhm.
what are the variables that you're being asked about?
What will be the new volume?
We're looking for, we're given volume and we're given a what?
The
Pressure.
pressure.
So for this, you ignore the temperature, okay?
Okay.
So you essentially are just working with pressure 1 times volume 1 equals pressure 2 times volume 2. But look, that is Boyle's law, right?
Mm-hmm.
But you already have that relationship right here. You know that you have to use that. Just ignore temperature, okay?
Mhm.
All right. So which one is your P1?
That would be 99.0.
Yes. And then you're going to multiply that by your V1, which is?
300.0.
Good. And then that equals, what is your P2?
Is that 188?
Yep. And then that's times X, or V2, whichever variable you want. Now, all you have to do after that is algebra. So solve for X. Jordan, type your answer in, please.
For oops.
For number 1.
Where did you go? There it is. For the first one, 99 times 300 gave me
Type
29,007.
it in. Type it in.
Okay.
It's easier to check when it's typed than when you say it out loud. No. Hold your work up. Keep it still. Nope, move it down.
Yeah.
Stay there. Your problem is on the other side. You have 300 twice. That is not true.
Oh.
Look, you are trying to find what pressure and what volume you have. The first pressure that they gave you was what?
99.
99 kilopascals. The first volume they gave you was what?
300.
That's why you have 99 times 300 on the left. Okay? And then you have equals. What is your second pressure?
188.
188. What is your second volume? Do you know that?
No.
No. So you put 188x because you don't know.
Figured it out.
Right? So Jordan, you don't write 300 again because it's not.
Okay, that's where I was confused because I wasn't sure where to put the X.
Well, you put the X. Look, Jordan, whichever of the variables is unknown, whichever one you're looking for, that's where the X goes. And look, if you're dealing with this and you only have pressure and volume, ignore the temperature. You only have these 4 things: pressure 1, volume 1, pressure 2, volume 2. You ignore the temperature when you're using this way.
Okay.
So all you have to do is say, hey, what are they looking for? They're looking for a volume. So that's where your X goes. Your X is always going to be what they ask you for. They say, what is the volume? That's X. Make more sense?
Yes, and give me one and I'll have the answer.
Now go ahead and solve for it. Emily Mongold, you type in your answer for me for number 1, and I'll check yours. Include a unit for me. Make sure you're not getting lazy because Jordan, you didn't write down your units like kPa by the pressure and milliliters by the volume. Make sure you write those down because otherwise you're going to get into trouble later when you're trying to label your units, okay? So even in the work, make sure it's there. Emily, did you type your answer in yet? Because it hasn't shown up. Good, Jordan. But now we need to do sig figs. We'll talk about that in a second. All right, so
I just did 2. Figured.
All right.
Anything from Emily Carr?
Good. So you guys, it's 158 with sig figs, and that's milliliters. So that's actually not a capital M and a lowercase l. It's actually supposed to be a lowercase m and then a capital L.
Really?
Yeah, milli is small. A capital M means mega.
Mm-hmm.
So remember, King Henry died by drinking chocolate milk. Above kilo is mega. And so that's like, if you put a capital M, you're implying something bigger than kilo.
Okay. Cool.
So that's why you have to have a little m if it's milli.
All right.
But that's okay. You got it. And yes, just like that. Now, Jordan, I haven't heard from Emily Carr yet. I don't know what's going on, but we're going to teach this lesson and she can come back and rewatch it afterwards because we got to get going. It's 2:14, so we got to keep working. So I need you guys to work on number 2 for me now. On page 443, solve number 2.
Okay. These are somewhat easy. I hope I don't.
These are easy, Emily. That's it. Look. If you remember your equation, it's simple algebra. It's just plug and chug, find the unknown variable. That's all it is. This chapter should be a breeze. So
Okay, good.
So it's not a trick.
Work on number 2, page 443.
Yes.
Okay.
Oh, this is like ridiculously easy.
That's good.
I hope it doesn't get any harder.
What, Emily?
I said, I hope it doesn't get any harder.
It shouldn't. As long as you memorize your equation or are able to read the problems and figure out what you're looking for. All right, I want you to type your answer in for me, Emily.
Okay.
That's correct, but it's the wrong unit. Because look, they're saying the pressure, they gave you liters for volume and ATM for pressure. And notice that they had liters for your second volume. So what's going to cancel in the end?
Okay. Okay, so ATM?
Yes, the liters will cancel and the ATM is what's going to be left over. Okay? Look, Jordan, that's why I told you to write down your units, because when you divide, you're going to have your liters cancel or your ATMs cancel, and that's what's going to tell you what your final unit is, because it's the one that's left. It's the one that didn't cancel. Good. All right, now look, I'm going to have us go on because I want us to keep working on these. Turn the page. Turn the page twice. So first, we're going to start on page 446.
Mm-hmm.
Excuse me. And we're going to look at number 4.
Bless you.
Thank you. Sorry, guys. All right, really quick. Remember, anytime you're dealing with temperature, what must the temperature be in to deal with the gas law?
It must be constant.
Oh, wait, it has to be in Kelvin.
It has to be Kelvin.
That too.
If you're dealing with temperature, it must be in Kelvin. Okay? So when we come into Gay-Lussac and Charles, both of them are going to look at temperature, and I guarantee the problems are going to like to give you Celsius. So remind me, how do you change from Celsius to Kelvin and Kelvin to Celsius? What's that?
Okay. We're both raising our hands down here.
Yeah, you don't have to raise your hand. Just say it.
You add
Oh, okay, so that'd be
to Celsius, and then you subtract it when you have Kelvin to get to Celsius.
Good. So you're going to take and add 273 or subtract 273 based on which one you're going. But that's right. Don't forget to do it. Okay? All right, so let's look at the first one. What volume will the gas in the balloon at the right occupy at 250 Kelvin? Notice they were nice to you on this one. They already gave you the temperature in Kelvin, so you don't have to worry about that. But notice the balloon, and it's got 4.3 liters and 350 Kelvin. So look at our combined gas law again. What are we going to ignore this time?
The 2 T's.
No, we need T's because we need temperature.
The liters.
Oh. What are we not using? Are we using, look, this is pressure, volume, temperature. Which ones are we using in this problem?
We're using volume and temperature.
So ignore the pressure.
Okay.
The relationship here is really volume 1 over temperature 1 equals volume 2 over temperature 2. Do you see how that works?
Find volume 2.
And you're looking for volume 2. So that's where your X goes, right here.
Okay, I see.
So now you just plug in what the first volume and the first temperature were and what the first second temperature was, and you have X at the top. Now, I know it's probably going to be an insult to your intelligence, but I am going to work through how to cross multiply and divide. Just because
That's what we do. Okay.
I don't want to take anything for granted, and I don't want to assume that you guys already know how to cross multiply and divide. So I'm gonna actually step by step go through this one with you. So the first thing you always do is write down your equation, and then you start plugging things in. So what was my first temperature and my first volume?
So the first volume is 250, so that goes in the top.
Oh, no.
No?
Look at your clues. Look, what volume will the gas be at 250 Kelvin? The 250 is your what?
Temperature.
That's a temperature, not a volume. And it's not even the
bottom.
first. It's the, is it the first or the second?
It froze, sorry.
Okay. Well, look at the balloon.
Mm-hmm.
Is this what you're starting with or what you're ending with?
What we're starting with, I'm assuming?
What we're starting with. So the 250 Kelvin that you were trying to say was your first one is really your second one. So that's 250 Kelvin is T2.
My answer is to the right.
Give me just a second. All right. Hang on, Jordan. I will check it in just a second. Look at your work, though, while we're going through the work, okay? Just in case. All right. So what is my volume 1? And Jordan, you can still answer these. What is volume 1?
Volume 1 is 4.3 L. Sorry.
4.3 liters. Do you see that, Emily, where it's telling you the volume? Measure for volume.
Mm-hmm.
What is the first temperature, Emily?
350.
350 Kelvin. What's the first? What's the second volume? Well, we don't know. So what do we put there?
X.
Put an X. And what's the second temperature?
250.
250. So look, you should have it set up something like this, right? Now, every time I set up a problem like this, I cross multiply, set them equal, and then I divide. Okay, so what cross multiply means is you take and make like an X like this, see? And take the thing that's on the top here in this fraction, the numerator, and multiply by the denominator here. Take the thing from this numerator and multiply it by the denominator here, and then put equal sign and write this times this, write it down, and then put this times this here, okay? So we're going to go 4.3 times 250. Tell me what that equals.
1,075.
You are correct, 1,075. And now what are my units?
Liters.
Liters times what?
Kelvin.
Times Kelvin. Notice how I write that down and then I put equal sign. Now we're going to go through and multiply the other side. 350 times X is 350 Kelvin times X. All right, so so far that's the cross multiply. Now we have to divide. We need to divide to get X on its own. So what do we have to divide by to get X on its own?
The two numbers we have.
You would divide 350 on both sides.
Yes. Look, so we take and we're going to divide the 350 to get rid of it from this side. See? So that X will be on its own, but what you do to one side, you have to do to the other. So put divided by 350 Kelvin on both sides. Now look, if something is in the top and the bottom of a fraction, see, Emily, if it's the top and bottom, you can cancel it. So this cancels. So that's X now.
And the answer should be 3.07 Kelvin.
All right. And notice what happened to my Kelvins. My unit, what happened to the Ks? It's in the top and the bottom, so what happens to it?
They cancel.
They cancel, and we're left with which unit? What unit, guys?
3.07 liters.
Liters. Now look at your significant figures. Check the original numbers. How many are significant in the original?
2.
2. So we can only have 2 in this one, so we round that up to 3.1. Good. Any questions?
Yep.
Now look, the next one gives you extra information to try to confuse you. So it says a gas at 89 degrees Celsius occupies a volume of 0.67 liters. Oh, never mind. I'm sorry. This isn't the problem that does that. It does something else to try to confuse you. What is the thing that they're giving you to try to confuse you?
At what Celsius temperature?
Okay, so you're looking for Celsius temperature. What did they give you to start with?
Celsius, 89 degrees.
Uh-huh. Can you do this equation? Can you do this equation with Celsius?
No, yep.
No.
There you go. Look. To work with this problem, like we've been doing, it must be in Kelvin. The final answer, the temperature that you get after you solve, will also be in
Kelvin.
So you're going to have to change the 89 degrees Celsius into Kelvin first. Then you're going to have to plug it into your equation. Then you're going to have to solve for the temperature too. And then you have to change it back to Kelvin at the end. Got it? Let's do that. I have confidence in you guys. You can do this. Oh, and by the way, if you don't change it to Kelvin, you will get the wrong answer. I promise.
Sounds good. Why did it wrong?
When you guys have finished, type your answer into the chat.
I think I must have done something wrong. Our Are we supposed to convert this back into Celsius?
Yes, at the end you're supposed to convert it back into Celsius.
Oh, boy. I'm gonna have to redo it.
All right. First, I will say Celsius does have negative numbers, so that's not the issue, but this one's not actually negative. Jordan, how did you, all right, can I see your work? All right, back it up a little bit. Stay there. Let me see which problem this is. You need to number your problems for me in the future because it's hard to tell which one is which. All right, so let me see. Can you hold it a little more still, please? I'm sorry.
I'm trying.
I see. What I think I see is 0.67 liters over something for your. All right, so what I need you to do is put that down for a second and check for me because I can't read it. I see how
I
you
have 0.67 liters over 313 Kelvin equals 1.12 liters.
Hang on. Slow down.
Oh.
I saw the 0.67 liters, and what was your temperature on the bottom? What did you say that was?
313 Kelvin.
How did you get that number? Because that's the problem.
Because I was looking at the wrong number.
Hang on, ready?
Practice problem.
Okay, so here's what you need to remember. Kelvin equals Celsius plus 273. So what you have there is 89 plus 273. And if you looked at the practice problem and got the wrong temperature, that would throw you off. But you have
362.
362 is that temperature. That's correct. So that's going to help give you, hi, baby. That's going to help fix, Joel just got up. That's going to help fix the problem, is just that temperature wasn't correct. Now, Jordan, I think you had everything else set up fine. You just needed that starting point.
I read the wrong Celsius.
Okay, so just be careful when you're looking at your temperatures, okay? Emily Mongold, I want to see what you're doing so far. Go ahead and hold up your work and let me see.
It's all a mess. I don't think I can send it. Let's see.
Okay, so let me see. All right, stop there for a second.
I don't think I understand it.
You flip-flopped.
I did?
Wait. Never mind. Hang on. I might be wrong. Scoot it down a little bit more. Down. Right there. Stay there. Never mind. I was looking at the wrong part of the problem. So you have 0.67 on the top. You have 362 on the bottom. It's good. And you have good. And then cross multiply, you end up with 0.67x. That's good so far. Yeah, that's perfect.
It is?
Good job. Wait, let me see the last thing. You have 605 Kelvin.
Over 273, and I subtracted that?
See, so it's just 605 Kelvin minus 273.
Yeah.
And that's it. So once you subtract the 273, you ended up with?
305.
That's the wrong, when you subtract. Hang on. All right, so type in your calculator 605 minus 273. It's not 305. You see?
Okay, I could have put something in here.
I think you just typed it in wrong.
Okay.
Because everything was set up and done right.
Yeah, I got 332.
Good. Now, Jordan, do you have that as well now? 332 after you subtract?
When I multiplied 362 by 1.12, that gives me 405.44 K. And then I have 0.67x.
Okay, good. 0.67.
And I know where I messed up. I divided the wrong side.
So you had to divide to get x on its own. So you divide both sides by?
0.67.
Yes. So divide both sides by 0.67 liters. And that'll cancel your liters, and you'll be left with Kelvin. Don't forget to include the units.
Moment right there. I was using the wrong number.
Okay, so just look, be very careful to look at it, what's with x. and you want to get X on its own so you know which one to be the right number, okay?
Right.
All right, so then, Jordan, tell me what you get once you do that because this is important. Emily, you go ahead and start on number 6. You're ready.
Okay.
All right.
Jordan, once you divide that by the right number, what did you end up with for Calvin?
I am typing it in. And then
Good.
just put the Kelvin.
Good. Now, Jordan, that's Kelvin.
Yeah.
Change that back to Celsius for me by doing what?
Subtracting 273.
That's it. So go ahead and take that number minus 273 and tell me what you get.
Yeah. No.
Good. Now, how many significant figures do you get to keep?
I'm guessing only none. None to Celsius.
No. Significant figures. Look at your original numbers. How many did 89 have?
2.
How many does 67 have? 0.67, sorry.
3.
No. Find the first non-zero after the decimal.
It has 2.
2. Okay, and then how much does 1.12 have?
3.
Good. So look, you have 2, 2, and 3. You go with the lowest. So you're going to use 2. So take this number and rewrite it so it only has 2 significant figures. No, if you owed me $332 and you gave me 32, I would be very mad at you. Don't change the place value. You still want the 300 to be a 300. You still want the 30 to be a 30, but you need to have a not. There you go. Now give me.
My brain was slowing down right then. It was like,
That's okay. But don't forget, you can't change the place value. Think about it like money. If you owed me $332 and you said, I'll just round down to 330, I'd be fine. But if you rounded down to 32, I'd come after you.
And I would have to change my name, state, and address.
It's right. So don't lose the place value, okay?
Okay.
All right. Now start on number 6.
Okay.
What number?
Quick, you're gonna get me lost. Stop it. Stop it. Stop it. Stop it. You're not funny. There you go.
Okay, I think I did something wrong on this.
Okay, Emily. Well, first off, tell me, what did you end up with?
I have 303.
You did something wrong. Yeah. Okay, let's check. Let me see your work.
It's right here in this little box.
So 3 liters I see, and then you have X. All right, so let me see with the 80. So the first temperature is 80. So you had to change that to Kelvin by adding 273. And what did you end up with for your temperature 1?
Where is it? Temperature 1 I have 353.
That's correct. Good. So temperature 1 is 353. Then what do you have for your temperature 2?
I have 303.
Good. That's right. All right. So then you have to cross multiply. So you're going to take your 303 times 3. And what do you end up with?
909.
Good. And that equals the 353 times X, right?
Mm-hmm.
That's what I've got over here.
So to get X on its own, what do you have to do? Take 909 and do what?
Divide it by 300. Oh, I divided it by the wrong thing.
There you go. So divided by 353.
What I was thinking.
That's the problem then. That's it. So just like Jordan did on the last problem, you just divided by the wrong part. That's all. So remember, where is X? And get X on its own by dividing the thing that's by X off. Okay, so always think of get rid of what's by X. All right, so now let me see. 2.58 liters is correct. That's with the right number of significant figures as well. So did everybody get that now?
Yes.
3, 5, 3, 2, 5. Yeah, 258.
Good. All right, now look. You would not have gotten this if you didn't change your answers to Kelvin first from Celsius. So good job on doing that. We're all good. All right, guys, now turn the page. And here's what we're going to have to start doing. To save us on some time, what we're going to have to do is only do one of the practice problems, and you're going to have the other one for homework. Okay, so this is going to be the Gay-Lussac's law, which is going to study pressure and temperature instead of volume and temperature. So look, out of this, pressure, volume, temperature, he's going to study pressure and temperature. So which one are we going to ignore?
Ignore volume.
Ignore the volume, and you have this equation. See?
Yes.
So remember, look, I'm trying to do this to help you. You only need the one equation. You don't need to memorize Boyle's, Charles, and Gay-Lussac's and then the combined, right? All you have to do is know the combined, because if you know the combined, ignore the variable that's missing, and you'll be able to solve the same way, okay? Now, because I don't like the way they do this, look at number 9. You're going to have 8 for homework. We're going to do 9 right now. Number 9 gives you extra information. It gives you a volume, and volume is not something you need for this. So you can ignore it. So I want you to pretty much ignore the volume completely and look at the rest of the problem as is, okay? So notice how it says helium gas in a 2-liter cylinder is under blah, 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 blah. Ignore the 2 liters. The other numbers are what you need.
Noted.
Okay.
So go ahead and plug this in and use the values that you give for the other 3.
Will you give us problems like these on the top?
I won't give you extra information.
Okay.
But I will give you problems like these, just not with the extra information. If I give you something else, it'll have what you need and no more.
So just ignore the liter.
Yeah, ignore the liters because this is Gay-Lussac. You're not going to need the volume because he didn't study volume.
This is one question. What is the ATM stand for?
ATM is a unit of what?
KPA? Pressure.
Pressure. So it's pressure.
Okay, I think I just need to go back and memorize
Wait,
those.
quick, Jordan. Eyeballs, right here. Ready? You have to memorize your units of pressure. That's why I told you to memorize them last chapter. If you don't, you're going to go through the whole next chapter or 3, couple chapters, we're going to deal with pressure, and you're going to be like, wait a minute, what's this mean? And I'm going to be like, it's a pressure unit, and I'm going to get frustrated. So
I do have the notes. I just had to go back and read over it.
Yeah, well, you don't just have to read over it. You have to memorize them. Get very familiar with these units of pressure.
Mine.
That's yours?
No.
Yeah.
No. Don't. What?
Don't understand you.
Doesn't.
Can you?
I know where my cat
Happy child.
Yeah, he's James is home right now, so he's hanging out with Daddy. He's having a good time.
is.
Are you typing your answer in?
Who, me?
Yes.
Oh, no, I'm using my calculator.
Oh, got it. I'm sorry.
Yeah, that it takes a little while. Times.
Ding. Ding.
Yeah.
Ding.
Yeah.
If you want to put it inside. There you go. Put it in there. There you go. Uh-oh. There you go.
Got it.
No, I don't have.
What do you get?
It's right there in the chat.
No.
That's what I got too.
Okay,
Okay, good. I don't feel so bad.
let's talk about it. What's your first pressure?
1.12.
1.12 ATM is correct. What's your first temperature?
309.5 degrees Kelvin.
No. Wait.
That is your first temperature because it's 36.5 Celsius plus 273.
Yep.
So it's 309.5 Kelvin. That is right. What is your second pressure?
2.56.
And we don't know our second temperature, so that's my X. See? We all are set up like this.
Mhm.
I'm gonna predict what you did wrong. You probably, when we did the cross multiplying and then dividing, you probably both divided by the wrong number. So let's do this first. Cross multiply, we're gonna have what's 309.5 times 2.56?
792.32.
792.32. What are my units?
That's ATM times K.
Good. Equals 1.12 ATM X. All right. How do you get X on its own?
You divide 1.12 into both sides.
Yeah, divide both sides by 1.12.
That's what I did.
Hang on. All right, so now let me see. We have 707.42.
That's what I got.
Oh, I'm sorry. I just didn't read the problem carefully enough. This isn't our temperature 1, it's our temperature 2. We're looking for the initial temperature. I know where the problem was. Look, read it. It says, at 36.5 degrees Celsius, the same gas sample has a pressure of 2.56 atm. So the Celsius is with the pressure 2, not with pressure 1. What was the initial temperature of the gas in the cylinder? You see how it's asking for temperature 1, not for temperature 2? I went too fast through that. I didn't think.
So it's 792.32?
So this temperature is supposed to be here, and this X is supposed to be here.
Oh.
That's ridiculous.
See how that makes a difference, though? That's my fault, because I didn't take the time to read it carefully before I started. I didn't actually read the problem. I just looked at the numbers. That might be what you guys did, too. If that's what you did,
Yep.
we have to read the problem before we can just go through and plug and chug numbers wherever we want. They have to be in the right spot. So that makes a whole lot more sense. So let me do this over. So what we've got really is 1.12 atm over X equals 2.56 atm over 309.5 Kelvin. So 1.12 times 309.5. All right, so this is what you guys have now?
Yes.
Good. Now we have to divide both sides by
2.56.
Yeah, 2.56. I'm sorry.
Haha, big difference.
What is it?
There we go.
Shut it. Shut it.
135.40625.
That is a huge difference from 7
Now,
to
hang on.
7.
This is Kelvin. What do they ask for the problem to be in?
Celsius?
It's asking for an initial temperature, but look, because they gave us the first temperature in Celsius, this one has to also be in Celsius. They don't always have to say Celsius. If they gave you Celsius for the first temperature, the final temperature must be the same unit. So we have to turn this back into Celsius by subtracting 273. And by the way, it's okay to have negative Celsius. It's not okay to have negative Kelvin. Kelvin's absolute zero is 0. It doesn't go any lower. But Kelvin and Fahrenheit, I'm sorry, Celsius and Fahrenheit both have negative numbers on their scale.
Oh.
Negative 138.
Good. And then with our units, we're going to have only 3 sig figs, so this is going to be negative 138. Any questions?
Mm-mm.
All right. You will do number 8 for homework. Turn the page. I am not going to go through the combined gas laws with you separately. I'm going to look at it really quickly with you, though. See how in problems 11 and 12, they're going to give you all of the values. They're going to give you a pressure, a volume, a temperature, another pressure, another volume, and then maybe ask for the temperature or something like that. That's because they're dealing with the combined gas law. And you're going to treat it just like you treated the other things. You're going to plug in all of the values that you know and solve for the unknown by cross-multiplying and dividing. It's just the same.
Mm-hmm.
When you multiply, you're going to have to multiply this times this times this.
Mm-hmm.
You know, so you're going to have more than, you're actually going to multiply multiple things. Do you guys think you have the handle on that?
Yes.
Yeah.
All right, so you're going to have that for homework. We're going to keep going.
So numbers 11 and 12 for homework?
Yes. I'm going to type this into Edmodo, but so far your homework is page 448, number 8, page 450, number 11 and 12.
Got it.
Okay. All right, so we're going to keep going on. We're going to at least try to get into the first couple problems in 13.2. All right. So notice that 13.2 starts Avogadro's principle. And we've heard Avogadro's name before. Where did we hear Avogadro's name before?
Avogadro's number.
That's it. Avogadro's number is named after Avogadro.
2 times 10 to the 23rd power.
Yes. Did I show you the video about Avogadro, the cartoon?
Yeah, the guy died before he was recognized for his
Yeah, the guy died. What is a mole? That one? That's the
That's
guy.
the way it usually works.
That's the guy we're talking about right now. Okay? And then they accepted his thing after he was already dead, which is so sad.
Guy brought him an award, and it's like, oh, okay.
You know, like
right
he
here.
doesn't really know now that he was recognized for his work, but poor guy. All right, so here we go. With this, it's going to introduce us to a new idea for stoichiometry.
Oh
I
boy.
want you to tell me what our stoichiometry conversions are so far. We know how to convert what into what. What's one of them, Jordan?
Mole to mole.
Good. We can convert moles of A into moles of B. That's it. All right, what else can we convert?
Moles of A to grams of A to grams of B.
Pause,
What-
yeah. Stay there for a second. We
Moles
can convert grams to
eggs.
moles, right? So that's a conversion. All right, so hang on. Let me just type these in. We've got grams to moles. We know how to do that, right? We've got moles to moles.
And grams to grams.
And we've got not grams to grams. We can go grams to moles or moles to grams.
Yeah, oh, grams to moles, moles to moles, moles to grams.
Moles to particles. Avogadro's number.
Particles.
So we also have moles to particles or particles to moles, right? Those are 3 conversions we know so far. We're about to add a 4th one. All right?
Oh.
It's based on Avogadro's studies. What he
Okay.
found is that if you take any gas and you put it in a flexible container, okay?
Batman.
And you put 1 mole of that gas inside of the balloon and you put it at a temperature of 0 degrees Celsius and 1 atm. So the pressure is constant. It's a 1 atm and the volume, pressure, moles, temperature, all of those are the same, okay? It doesn't matter what the gas is, it's going to expand to a point where the container is this big and no bigger, 22.4 liters. That's the size. So, and I like to draw this out. Actually, they have it drawn for you already at table, page 452. So it doesn't matter if you have, hang on. Here's my balloon. See, my beautiful balloon. And I have 1 atm. 1 atm of pressure at 0 degrees Celsius, and I put in exactly 1 mole of the gas, right? Now, tell me a gas you know of. Any gas.
Oxygen?
Oxygen. Let's say we put O2 in here. This balloon's volume would be 22.4 liters. Let's say we switch the gas out, though. Instead of oxygen, we put carbon dioxide in here. What's the volume going to be?
Your turn, Emily.
22.4 liters. Let's say we take out the carbon dioxide and we put helium inside. What's it going to be?
22.4 liters.
Do you catch on? 22.4 liters is the volume that 1 mole of any gas will occupy at STP, which means 1 atm and 0 degrees Celsius. It's standard temperature and pressure. Standard temp is 0 degrees Celsius. Standard pressure, 1 atm. At that condition, any gas will occupy 22.4 liters. So can you guess what our new conversion for moles is going to be into?
Moles to gas.
That's it. So 1 mole of any gas will equal what volume?
22.4 liters.
That's it. That's our new conversion. We can flip this upside down and put 1 mole on the bottom and 22.4 liters on the top. So we can do this however we need, but we can now get from moles to volume and volume to moles. Does that make sense?
Yes.
And it's all because 1 mole is exactly 22.4 liters.
Got it.
All right. So let's look at the first thing. Of course, they're not going to be nice enough to give you moles right away. They're most likely going to give you grams. What do you do to convert then? Can you turn grams into volume?
No, you'd have to turn it into moles.
Turn grams into moles first, and then you can turn moles into volume, right?
Yes.
Yes. No. Yes, we can. All right. So let's look at number 20. What size container do you need to hold 0.0459 moles of N2 gas at STP? Hey, look, they're being really nice to you on this first one. So how do we set this one up? So we have 0.0459 moles of N2, and we're looking for volume. Yay, thank you. Good job. Kiss, kiss. Mwah. Here, you take this one. No, you want this back? How about you put it inside? There you go. Good job. Show Daddy. Go show Daddy. All right, guys. Here's my handy dandy stoichiometry table. What goes down here?
The 22.4.
No. Put your unit.
No, the grams.
I want a unit. What unit has to cancel?
N2. We have to put 1 mole down below.
Moles of N2. Moles of N2. Moles of N2 has to cancel, so moles of N2 has to go down here. What has to go on the top? What are we trying to turn it into? Volume. Are we allowed to go directly from moles to liters?
Yes.
Yes. So we can put volume on the top. Liters. Now, look. What numbers go here and here? Remember our balloon?
It'd be 1 mole on the bottom.
Good. And how much volume is 1 mole of N2 going to take up?
22.4.
22.4 liters.
So
If you
22.4.
divide it by 1, it'll just stay the same.
See, the 22.4 goes with the liters because that's the size that 1 mole of gas takes up. Does that part make sense, guys?
Yeah.
Now look, you're going to multiply by the things on the top and divide by the things on the bottom. So it's this times this divided by 1. Notice that your units, the moles are going to cancel, but you're going to be left with volume, liters. All right, so what is this? When you multiply 0.0459 times 22.4.
You get 1.0282.
All right, now give me significant figures. We're going to have how many?
1, 2, 3, 4, 1, 2, 3. We have the right amount, right?
No.
You
All right,
multiply it
let's
by
go back to our
10
moles.
it would be 10.2816.
No. All right, listen. Just listen, guys. Look. Look at your original number. If there's a decimal, find the first non-zero. Where is the first non-zero?
Okay.
Start
4.
left to right. The 4 is the first non-zero. Everything after that number gets to count. 1, 2, 3. How many significant figures?
3.
3. So our final answer needs to have 3. So where's the first non-zero here? Look, read
1.
Read like a book. Yes, the 1. So we start here at the 1. 1,
1.28.
2, 3. So we're going to stop at the 2, and because there's an 8 after, we're going to round up. So it's 1.03. Now, Jordan, you need to be careful not to shift your decimal. See how you wrote 10?
Right.
And if you owed me $1 and you gave me 10, I'd be really happy. You'd be really sad. Don't shift your decimal unless you have a reason or if you show it with an exponent, okay?
Right.
So the decimal still has to be 1. All right. Any questions about that part so far?
No.
All right. I want you to start on number 21. How much carbon dioxide gas in grams is in a 1 liter balloon at STP? So you're going to start with what volume?
Carbon dioxide.
Yes.
It'd be
But what,
22.4.
no, what volume do they give you?
1.0.
1.0 liters
Mm-hmm.
of CO2. That is your starting point. Now look, you can't go from liters to grams directly.
You had to go to moles.
You have to go to moles first. So what has to go down here?
22.4.
So look, I just want the unit right now. Don't give me numbers yet. Which unit goes on the bottom to cancel?
Oh, liter.
Liter.
Liters. CO2. What unit goes on the top?
1 mole.
Mole.
Mole. Good. CO2. Now you're right. It is 22.4 liters and 1 mole. But notice how you can plug those numbers in after you've got your units in, and it's a lot easier after you put the unit where it belongs to put the numbers with the unit.
Mm-hmm.
Do that then. Put your units where they need to be and then put the numbers with them. See? All right, now that we've got liters, look, liters will cancel, and I'm going to be left with moles. How do I turn moles into grams?
You put the molar mass of CO2.
Good. So what's going to go on the bottom?
The molar mass of CO2.
Not the molar mass. Look, unit. Give me your unit.
And then molar mass goes on top.
1 mole of CO2 on the bottom, and then we're going to do grams of CO2 on the top, which is 44.01. Wait, 44.2. Hang on, let me just make sure. That's 1632, and then it'll be 2.1. Yeah, 44.01. I didn't want to waste the time having you guys look it up, but that's the number, 44.01. Okay, now multiply on the top. So like you're going to go 1 times 44.01. Type that in right now. Then push equals, and then push divided by 22.4. So essentially you're going to have
985.824.
You would round up because it only has their significant figure would be 1. So it'd be 2 grams CO2.
Look at your significant figures at the original. How many in this number? Where's
2.
the first non-zero?
1.
1.
1. Everything after that is significant. So there's 1, 2 significant figures.
It'd be 980.
So we're going to write this as,
9 grams CO2.
all right, hang on. Let me show you guys how to round this. 1.96, right? So I agree with you. It should end after 2 numbers. But look what happens when you try to round that. The 6 is going to make the 9 do what?
So it'd be 2.0.
Yes, because the 6 makes the 9 round up. So you have to have this as 2.0. That has to have the 0 there. Otherwise, you don't have the right number of significant figures.
So technically, I did answer it correctly the first time.
But you had the wrong number of significant figures. Yes.
Would you still let that one slide on the test, missing a 0?
I would take off points. I would take off points because it's not the right number of significant figures. Just make sure you do it right. Okay. I'm going to assign you a couple of these for homework. But I'm not going to start in on the next thing, which is the pervert, the ideal gas law. What we'll do on Thursday when we meet in person for class is Thursday we will cover the practice problems for the ideal gas law, and we will start into and finish the gas stoichiometry on chapter 13.3. So that's what we'll do on Thursday. So the rest of your homework is going to be to finish these practice problems on this page. Page 453, numbers 22 through 24. That's it. Those are your problems.
22 through 24?
Yeah, 22 through 24, which means you also do number 23. All right, look, I have to be very, very honest with you guys. You will not do well on this if you do not practice. You can understand it all you want. If you don't do the work yourself, you will never remember it on the test day or the quiz day. All right, you have to put in some real work on these, okay? So don't show up on Thursday with an excuse. Just show up on Thursday with your homework done. You only have 1 video to watch. There's these problems, and then you have to do your project. Which you wait, is the project, I know I backed it up, but I don't remember.
On Edmodo, it says that it's not due till Tuesday.
Is it the next Thursday or is it this Thursday? I don't remember which Thursday I said.
You said next Thursday.
Got it. So you guys are just working on the project until that due date, which I think is on the 10th. I know that I had pushed it back so you guys had more time, so you would have 2 weekends, but I couldn't remember which Thursday we started, so there we go. I am going to let you guys leave if you don't have questions for me, but I'm going to stay for a couple minutes in case you have any questions about your project. I will be able to answer them. Now look, hang on, Jordan. I know you haven't started on it because I know you asked me where the directions were for it, you know?
Yeah.
So
yeah, that's what I was looking for. I know how to start it now.
Okay, good. Look, I expect next video for you to have something for me to be able to ask you about, okay?
Okay.
All right, Emily, how about you? Jordan, you can sign off then. Emily, have you started?
Yes, I have.
Good. How much have you gotten done then?
Not a whole lot on gas right now.
Okay,
I
so
realized I did a whole bunch for one slide on gas, like too much information that answered all the other questions, so I'm trying to space it out.
yeah, so you just have to space it out now. And don't forget to include a lot of examples, okay? So like real life examples, pictures, videos, whatever you can link in, all right? All right, well, let me know if you need any help with it. Otherwise, I'm going to say bye.
All right, thank you. We'll talk to you later.
No problem. Bye.